Okay. So for our project, we used neural networks to classify different types of blood cells. And so the reason this problem is relevant is because creating a classifier like this can help medical professionals make more informed diagnoses when diagnosing different types of diseases. And so we used a Kaggle data set with 4 different blood cell types that we were classifying, as you can see here. And we used pretty simple like image rotation type augmentations on the images in order to create our data set. So in order to create our solution, we first chose a baseline model to compare our 4 models to. So each of us made a model, compared it to the baseline model, and then we took all of the best features of each model and then put it into a new model in order to see if that was actually going to improve the accuracy. So our baseline model was the VGG16, which was chosen because it was a well-known model that has performed well in the past. And so we thought it would be a good baseline model to compare to. ResNet is the model that I implemented. It was implemented in order to incorporate more layers in the network without increasing error along with that. It was also made for the ImageNet competition. And this network utilizes skip connections to jump over layers inside a residual block. And this allows the network to be simplified, and you were able to add more layers without increasing error. And these residual blocks are repeated in order to make up the network.
I implemented the Google Net, which is a variation of the Inception nets. The Google Net is known for its ability to learn features with varying scales. The Inception module takes advantage of multiple convolutional layers at varying degrees of kernel sizes, so that while it learns the same features, it learns different scales of those features, so it can learn different amounts of information at the same time.
I implemented the CRNN architecture, and what it is a concatenation of the outputs of a convolutional and recurrent neural network. And the motivation behind implementing this model was that convolutional neural networks on their own lack the ability to recognize repeated features and call back from memory the way that specific classifications of cells look. And the reason why we wanted to integrate a recurrent neural network into this structure is so that we can mimic how a human medical professional or physician would classify different cells in their line of work. Additionally, there have been repeated instances and works that have shown that CRNN models perform better as opposed to using only convolutional neural networks.
I implemented a squeeze excitation block on top of the convolutional neural networks. And so by adding this SE block function, it on a high level reweighs the features after each convolutional block. This was added into a model inspired by VGG19. And this also gives us some better accuracy and efficient learning without adding too much more additional computational power. And we can see that at earlier epochs, actually, there is even some earlier overfitting and accurate classification than the traditional VGG19.
So to evaluate all of our models, we trained for 100 epochs, and most of our models performed decently well, ranging between 70 to 85% accuracy. And the best models that we trained were the squeeze and the ResNet.
So taking all of these models into account, the model that we proposed is a combination of the VGG16, the Google Net, the ResNet, and the squeeze excitation convolutional neural network. Essentially, it follows a similar architecture to VGG16, but instead of convolutional layers, they use a squeeze excitation inception ResNet block. By doing so, we were able to achieve 94% training accuracy with a validation of 73% accuracy at just the first 3 epochs, which means it performed very similarly or almost outperformed every other model at just the first 3 epochs. When trained for the full 100, the IRS net, which is what we termed this proposed model, reached a final accuracy of 99% with training and a validation accuracy of 88%.